Hi my dear students, welcome to one more amazing session from Infinity Learn. This is Suresh, faculty of chemistry. How are you all? Waiting for high scoring reactions from the organic chemistry. Can you believe today's class we are going to squeeze the marks like anything. So take a pen and paper everybody, follow the reactions along with me, and so that one round of preparation is also completed during the live session. Can you believe? And hi Sobia, Rutu, good morning, and very nice to see reappearance of the students are increasing in the session. So please attend our class and attend the class on live basis so that you can have a very good interaction between you and me. And Betu is there in today's class. You can use the chat box to ask various kinds of doubts and high score reactions in the organic chemistry. You are all preparing for NEET examination in that organic, inorganic and physical chemistry. In the previous class, we had seen the inorganic chemistry, high yielding reactions, and today we will see a bit of organic reactions, the corners of the organic reactions where you have to maintain focusing there, and you're going to get absolutely good questions, and correlated to the reactions that I am giving right now will be given an example of previous NEET examination as well. Get ready. So please confirm those students who are online. Are you able to hear me? Can see me? Just give me thumbs up and fire emoji to start the class. Wonderful. Sobia, Rutu and Betu is there in today's class? Yes. Radhe Radhe. So without your presence now, the class is not going to be that awesome. All the students with beautiful minds are attending our class, and all the best for your NEET examination journey. In this NEET YouTube channel by Infinity Learn, we are going to give various strategies and various concepts for preparation of NEET examinations. So you may feel that just attending the class on the YouTube channel, can we clear the NEET examination? Yes, of course, undoubtedly you can clear. Not only you can be clearing, but you can be a topper as well. Believe it, it is true. And it has proved in 2024 and 2025 NEET examination. Personally, I observed the students. Hi Sobia, Betu, let's start. Without any time delay, take a pen and paper and write the reactions along with me. So the first and foremost organic reactions, Grignard reagent is the one. So what do you know about the Grignard reagent? If you are going somewhere without Grignard reagent, no examination paper. So let's talk about high scoring reactions that we can see the Grignard reagent. Grignard reagent देखने के बाद आपको क्या लगेगा दिमाग में? So Grignard reagent is RMgX, R minus and Mgx plus. And this is going to be very good, a strong base and excellent nucleophile. Now let us discuss about the two statements I have written there. Sobia, this class is going to be 1 hour class beta. So what is the meaning of a strong base? A base is the one which attack at H plus. So any species it reacting with a Grignard reagent with a labile hydrogen or acidic hydrogen, it is going to give you its corresponding alkane. You know, that's why Grignard reagents are prepared in anhydrous conditions. अगर anhydrous condition नहीं होगा तो moisture मिलेगा. Moisture का मतलब है थोड़ा सा water molecule है. Water is going to react with Grignard reagent to give rise its corresponding alkane. Not only water, alcohols, amines, acids, carboxylic acids, acetylenes, and anything, it is going to straight away gives rise its corresponding alkane. And Victor Grignard made this reagent. When alkyl chloride react with magnesium in dry ether, you are going to get alkyl magnesium halide. And this alkyl magnesium halide is called Grignard reagent, and Victor Grignard got the Nobel Prize for this. So let's see, it is an excellent nucleophile here. What is the nucleophile? What is the definition of a nucleophile? Somebody in the chat box, you just give me the definition of a nucleophile. A nucleophile is a species which can attack at the positively charged carbon. Children, you have various tools that are available in Infinity Learn NEET. You just click it and you can talk to Aina also. And talking about the Grignard reagent, Grignard reagent is a good nucleophile. It can react with carbonyl carbon. So that this is going to react with carbonyl carbon to gives its corresponding alcohols. Grignard reagent react with the formaldehyde. It gives rise a primary alcohol by hydrolysis. Grignard reagent react with any aldehyde other than formaldehyde. You are going to get a secondary alcohol. Grignard reagent gives rise, Grignard reagent react with a ketone followed by hydrolysis gives rise its tertiary alcohol. Sodium, a nucleophile is an electron-rich species that donates an electron pair to an electron-deficient center to form a new covalent bond. Electron donates to positively charged carbon. Betu, a nucleophile is a chemical species that forms a bond by donating a pair of electrons to an electron-deficient center, usually a carbon, but not H+. So, nucleophile and base, both are same. But a base, if you define, you consider H+, a nucleophile define, it's considered C+. So, that is a key point to identify the difference between a base and an acid and a base and a nucleophile. And you can see the Grignard reagent, formaldehyde primary alcohol, Grignard reagent with an aldehyde secondary alcohol, Grignard reagent with a ketone gives us tertiary alcohol. It is clearly mentioned in the NCERT. So, this is what is called route map, or you can make a flashcard with that. You have to make it. Before examination, you can just open it and you can revise 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 reactions for Grignard reactions. 10 reactions एक ही नजर में आप revise कर सकता. That is the power of mind maps. Like that, so many mind maps are ready and we will do the best out of it. Agree? Take a screenshot, everybody. Grignard reagent is going to react with an ester and it is going to form an alcohol, corresponding alcohol. So, when Grignard reagent react with an ester or acid derivatives, it is going to consume 2 moles of Grignard reagent. Just that is very important. Maximum of 2 moles. Grignard reagent react with any acid derivative. Y is the leaving group. It could be chai, isko halogen ho sakta, or it could be thio groups, or it could be an acid anhydrous, whatever. You are going to get its corresponding carbonyls. And you are going to react with amides. Grignard reagent is going to react with carbon dioxide to give us a carboxylic acid. हर reaction को आप hydrolysis करना बाद में. Karim, hello, good evening. And you can see Grignard reagents are going to react with these carbonyls, unsaturated carbonyls. You are going to get its corresponding enols, and this enol is tautomerized to give rise its corresponding alcohols and ketones. And this is how it is given. Now let us see the Grignard reagent, various reactions. The major product of the following. This was the reaction given in NEET 2025. It is blasted like anything. This question has blasted like anything. NEET PYQ 2025. So, इतना complex नहीं है, इतना complex नहीं है. So, as I said, this C double bond gives rise, it's a ketone, tertiary alcohol. This is a CN, gives rise to OH groups. But here the thing is, it is not exactly you feel it. People misunderstood this is going to be the answer. But this is wrong. This is wrong. Karim, could you tell me what could be the actual answer for this? So, this how Grignard reagent you prepare. This is the concept of Grignard reagent. You already had a preparation, but this is how the question can be. This is the question can be. Beto, option 2 is the correct answer. Why and how? So, Grignard reagent is taken in excess so that it can react here and as well as it can react here. Karim, that's fine, wonderful answer. And it gives you the structure like this. And it is going to give you O minus MgBr. And it is going to be CH3. And it is going to be C double bond N, and it is going to be CH3. And what are the things left? H2O. No, Sobia, it is not that. Then when you hydrolyze this, so what happened? The excess Grignard reagent that is there, excess Grignard reagent that is left, CH3 MgBr, CH3 MgBr. So this acid hydrolysis that is used in the step 2 is going to kill this, because Grignard reagents is going to be reacted with water, and this is going to be hydrolyzed, this is going to be hydrolyzed. As a result of this, the product actually you are going to get is going to be C double bond O and CH3, and it is going to be CH3, and it is going to be OH. If that is the case, the answer for this question is going to be 2. This was a NEET examination question asked in 2025. Six months ago, the question has been asked, not in the long history. Yes, this is going to be carbon atom number 1, 2, 3, 4, 5, and 5 hydroxy, 5 methyl, and 5 phenyl. So 6, this is 6. So 5 hydroxy, 5 phenyl, hexane 2 one. Hi. Aksar, good evening. Now, let us talk about some more reactions that you can see from the Grignard reagent. All these reactions. Previously, I have shown just only 14 reactions. Now you can see how many reactions that it can form the Grignard reagent. And you only have to work with this Grignard reagent. Grignard reagent can react with anything like carbonyl compounds it can react, and cyclic ethers it can react. It's a wonderful reagent. And you can see this Grignard reagent usage is versatile, because Grignard reagent is going to be a strong base and excellent nucleophile. Aksar, hope you like this. Everybody who are online, please like the session. Please like the session. So when you like the session, the like button is going to be visualized. So bacho, without delay, we will see some more reactions here. Some more reactions. Ready? Aksar? Take a screenshot, everybody. Take a screenshot. 3, 2, 1. Now moving ahead, nucleophilic substitution reactions. These nucleophilic substitution reactions. A nucleophile is substituting a group or an atom, and that can be done on the sp3 carbon atom, that can be done on the sp2 carbon atom. If it is an sp3 carbon atom, it could be SN1 reaction or is SN2 reaction. If it is sp2 carbon, it could be haloarenes or it could be on acid derivatives. If it is haloarenes, you can say SNAR2. If it is an acid derivatives, you can say it is SNAC twice. Okay. So nucleophilic acyl substitution, we will be seeing everything in today's class. So bacho here, so that route map you need to have. And let us talk about first SN1 reaction. It is a unimolecular nucleophilic substitution reaction. and connected with SN1, SN2, you will be having a question in the NEET examination like, so which of the following is most reactive towards SN1, which of the following is most reactive towards SN2, and which of the following undergo nucleophilic substitution reaction, like that. So anyways, nucleophilic substitution reaction, one unimolecular is a single step reaction. In this single step reaction, you can say rate of a reaction is equal to K alkyl halide. So if it is a two-step reaction, it is a two-step reaction. So two peaks will be there, carbocation is going to be formed. My dear students, so the leaving group is lost by the solvent. That's the reason why SN1 reaction is otherwise called as a solvolysis. So one leaving group is lost, you're going to get a carbocation. This carbocation is sp2 again, triangular planar. Now the nucleophile can attack here as well as here to form its racemic mixture. So I want to say it is a two-step reaction, and reactivity tertiary is more than secondary is more than primary, because Betu, the reaction is dependent on alkyl halide and independent on the nucleophile. So order of the reaction is going to be 1, and unimolecular reaction. So you say it is SN1 reaction. Fine. So you clarified your doubt, and you see the logic to crack this question, reactivity in SN1 is directly proportional to stability of carbocation. It is directly proportional to the stability of carbocation. And at the end of this, you are going to get a racemization is seen, because the nucleophile can attack from the front side or as well as backward side. And you need to use a powerful solvent so that leaving group is going to be kicked out. So we need a polar protic solvent. We need a polar protic solvent. And once the carbocation is formed, then only nucleophile is attacking there. So you need not have to expect a strong nucleophile for this process. So I would say this is going to be a weak nucleophile favors SN1 reaction. So we are fine. So I don't want to give you big notes in single sheet and one slide. Total SN1 is self-explanatory. Mayank Chaudhary, hi, good morning. So moving ahead, let us talk about SN2 reaction. So you written something I can't understand, it is a single step reaction. Now we can see the rate of the reaction is equal to nucleophile concentration to the power 1 and alkyl halide concentration to the power 1. Order is going to be 1 plus 1 is equal to 2, bimolecular reaction. That's fine. And the reactivity for both SN1 and SN2, alkyl iodide is more reactive than alkyl chloride is, bromine is more reactive than alkyl bromide is more reactive than alkyl chloride is more reactive than alkyl fluoride. When it comes to the reverse here, SN2 primary is more reactive than secondary alkyl halide, more reactive than tertiary alkyl halide. When you talk about SN1 reaction, reactivity of SN1 reaction is directly proportional to the stability of carbocation. This alkyl chloride, ज़्यादा स्टेबल कार्बोकेटाइन बना सकते हैं, ये SN1 में तुरंत जल्दी पहुंच सकते हैं. Now when he is talking about SN2, look at the steric reagents. Reactivity of SN2 inversely proportional to steric hindrance. बल्कि ग्रुप ना करना बेतो. When the nucleophile is trying to attack at the carbon of the positive charge, so there will be a situation where old bonds are not exactly broken and new bonds are not exactly formed. That situation is called as a transition state. जब न्यूक्लियोफाइल कंप्लीट बॉन्ड फॉर्म कर सकते हैं, लीविंग ग्रुप यहां से निकालना पड़ता. whenever leaving group is lost, nucleophile made a complete bond. So ये ट्रांसिशन स्टेट एक स्टेप नहीं होगा बेटा, फ्रॉम हियर टू हियर इज अ सिंगल स्टेप, ताकि इसका ग्राफ एक ही पीक मिलेगा. सो विच ऑफ द फॉलोइंग ग्राफ एक्सप्लेन्स SN1 और SN2? SN1 का 2 peaks and SN1 का 1 peak, single step reaction. And you know, the nucleophile wanted to go and attack there. इसका strength ज़्यादा होना चाहिए. So a strong nucleophile favor SN2. While you can see the solvents, polar aprotic solvent. Favors the SN2. And I want to say reactivity of this is same for both SN1 as well as SN2 को भी इस्तेमाल कर सकता. Are you getting or not? Clear बेतु? तो भैया take a screenshot everybody. Yeah. Now let us talk about alkyl halides. And there is always a confusion between elimination. Hi Nitin Anshu. Hi. Please like the session. There is always a confusion where a nucleophile and where an elimination takes place, where substitution takes place. So let me tell you a beautiful example where so I want to use the space that is here. Okay. A quick revision of this. Nitin, look at this, CH3 and CH2Cl. If it is treated with potassium hydroxide aqueous and potassium hydroxide alcohol, and you heat it, what are the actual products? Nitin, look at here. In the presence of aqueous, you are going to see CH3, CH2OH. You are going to get a nucleophilic substitution reaction, चाहे इसका SN1 हो सकता है, SN2 भी हो सकता. Now, you will get here CH2 double bond and CH2. It is an elimination reaction. It could be either E1 and E2. During a reaction, मान के चलो बच्चों, SN1 always competes with E1 and SN2 always competes with E2. E1 is elimination unimolecular and E2 is elimination bimolecular, Nitin. So when you proceed the reaction, you are going to get a product of both substitution as well as elimination. Experimentally it is appearing like that. Sometimes substitution product मेजर हो सकता, sometimes elimination product मेजर हो सकता. Condition क्या होगा? It depends on the temperature. Whenever at high temperature, always prefer elimination. Whenever use low temperature, depends on the bulkiness of the base and the leaving abilities and acidic nature of alpha hydrogen, elimination and substitution range is going to be varied. And कैसे करेंगे एलिमिनेशन? एलिमिनेशन में कुछ खास बात नहीं है बेटा. एलिमिनेशन रिएक्शन में देखो ये जो CH3 है ना, सो CH एंड CH2 उसका एक क्लोरीन है एंड इसका एक हाइड्रोजन है. डीहाइड्रो हैलोजनेशन करना, एक हाइड्रोजन एक हैलोजन निकालना. ये तीनों हाइड्रोजन ने एक हाइड्रोजन निकालना चाहता हूँ. एक हाइड्रोजन क्लोरीन, so it is going to be lost as HCl in the presence of potassium hydroxide or sodium hydroxide alcoholic and heated. So जब ये हाइड्रोजन एंड हैलोजन ये दोनों के बीच में निकाल दिया ना, so a new pi bond is going to be introduced between these two. CH3 हाइड्रोजन से एक हाइड्रोजन निकाल दिया, दो बचेगा एंड ये CH2 होगा. पहले से दोनों के बीच में एक ही बॉन्ड था ना, अभी तो दूसरा बॉन्ड लगाना. अल्कीन, you understand, this is what is called as a beta elimination. This is what is called beta elimination. नितिन, हैप्पी? क्लियर? अगर कुछ डाउट है ना तो चार्ट बॉक्स में पूछना. आई एम गोइंग टू हॉनर योर डाउट. Nitin, fine. So let's see the alkyl halide can undergo elimination reaction as well as. Thank you. Vansh Shukla, focus here. So Sobhya का हाई बोल रहे हैं, तो सर को नहीं बोल रहे हाई. हाई वंश. So this is your bromine. So it is a primary alkyl halide. This is your primary alkyl halide, है ना. So when it is treated with methyl alcohol, you undergo only SN2, 100% you are going to see OCH3 is going to be formed ether. So because this OH has a lone pair of electron is going to attack as a nucleophile ताकि ये bromine निकाल दिया. Clear? Now if it is taken as a base, CH3O minus or any OH minus is taken, you are going to get elimination product traces and you are going to get again a major product SN2. And CH3O minus is less bulky, so it is going to be a more nucleophilic than a base. So I'll give you the other combinations also, bacho. If it is taken this as a tertiary butoxide, you can see इतना मोटा दिख रहा है ना, so that it is a bulky base. So when alkyl side is increased, its nucleophilic strength decreases and basic strength increases. अगर base, जब base आता है ना, elimination नहीं करना, so it is going to get dehydrohallucination ताकि इसका आपका मेजर प्रोडक्ट इवन CB का हिसाब से सिर्फ एक ही आल्केन निकलेगा. सो दिस इज ए क्रिस्टल क्लियर पिक्चर दैट इज obtained. दिस इज अ क्रिस्टल क्लियर पिक्चर दैट इज obtained. सो कौन सा प्रोडक्ट कब देना, किस कंडीशन में, इट इज गोइंग टू बी सुपर इंपॉर्टेंट. एवरीबडी टेक ए स्क्रीनशॉट ऑफ दिस. So moving ahead, yes, we can say it's a strong base. And और एक चीज है, अगर प्राइमरी लेना चाहते हो तो प्रीफर SN2. ट्रिक, प्राइमरी अल्काइल हैलाइड प्रीफर SN2. Now, this is your secondary alkyl halide. This is going to be a mediocre. It can have nucleophilic substitution reaction as well as elimination reaction together. And you can see when it is methyl alcohol, okay, it is going to be nucleophilic substitution reaction. So, it is going to get 70% of this, a little bit of minor product elimination reaction bhi ho sakta. While you can take CH3O minus, it's a base, now it is a base. In that case, elimination is preferred over substitution. Now, when you take tertiary beta oxide, always with irrespective of the reactant, you are going to get only alkene as a product. All the time, tertiary beta oxide prefers elimination. So, it is mix match. It is a version 2. Now, मैं आपको पेश कर रहा हूं, पहले आपको प्राइमरी दिया हुआ ना, प्योरली प्रेफर SN2. Hi Subhasini. Now, if you take as secondary alkyl halides, it may take elimination as well as substitution. Both are possible. When you take tertiary alkyl halide, this is your tertiary alkyl halide, it prefers this is your trick. This is your trick. You can see tertiary alkyl halide and you are going to get SN1 major with ethyl alcohol and traces of E1 method. While you take methoxide and tertiary beta oxide, always elimination is the major product. That is my trick. So, these particular slides, primary, secondary and tertiary, the tricks that I have given, it is going to be a super awesome examples and directly you can go ahead with NEET examination question cracking करने के वक्त में ये दिमाग में रखना है and take a screenshot everybody, take a screenshot everybody here, primary, click 3, 2, 1. Now, this is the secondary, everybody take a screenshot, 3, 2, 1. And talking about the tertiary, I have written the tricks, click 3, 2, 1. So, hope you like these slides. ज़्यादा मेहनत किया सेशन का आने के पहले, स्टूडेंट को कब देना, क्या देना. I am more enthusiastic to work so heavy and strong for my students. Hope these presentations are helping you guys. Betu, Nitin stopped asking doubts. Betu also stopped asking doubts. So, I usually comes to NEET YouTube channel. So, I love to take YouTube classes. I will be why the reason is I have a chance to enjoy with the students when they are asking doubts. I really enjoy the chat with them. Don't you? Betu, Subhashini. Yes, thank you. Moving ahead. This is a overall. So, you are preparing for your organic chemistry. You make the sheets like this. Prepare the sheets like this. You can do the best. Right. Now, alkyl halides. So, R, CH2, Br. So, it could be Br, Cl, OTS or any other good leaving group. So, what are the reactions that it can undergo? It is according to NCERT textbook. So, alkyl halide hydrolysis gives rise alcohol. Alkyl halide react with alkoxides gives rise ethers. Williamson ether synthesis. Williamson ether synthesis. आज का सेशन जो टॉपिक है हाई यील्ड ऑर्गेनिक रिएक्शन नेम्स. So, this is the best way to prepare, right? Sobia and Subhashini. And whenever it is reacted with sodium hydroxide or potassium hydroxide, So you are going to get alcohols. The problem है कि elimination भी आ सकता है इसका, elimination भी आ सकता. Elimination के जो conditions दिया पहले में, and it is reacted with potassium thalamide, and potassium thalamide is a very good nucleophile, Gabriel thalamide reaction, followed by hydrolysis gives rise to primary amine. बच्चों, primary amine, you're going to get a primary amine RNH2. This is a primary amine. This reaction is Gabriel thalamide reaction. When alkyl halide react with SR, you are going to get a thiol alcohol. This is also kind of Williamson ether synthesis. So what general type of reactions are known originating from RCH2 Br molecule? So these are all the reactions. We can see how many reactions: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 reactions. So just 10 reactions, haloalkanes is done. Betu, haloalkanes are done, just 10 reactions. Now you can see alkyl bromide, when it is treated with ammonia, is going to get a primary amine, secondary amine, tertiary amine, quaternary ammonium salt. Hoffman ammonolysis reaction. Hoffman ammonolysis reaction. Alkyl halides can be reduced either by lithium aluminum hydride or sodium borohydride. You are going to get an alkane reduction. लिथियम अल्यूमिनियम हाइड्राइड प्राइमरी सेकेंडरी अल्काइल हैलाइड को रिड्यूस कर सकता, टर्शियरी अल्काइल हैलाइड रिड्यूस नहीं कर सकता, अल्किन बनेगा. सोडियम बोरोहाइड्राइड प्राइमरी को नहीं कर सकता, सेकेंडरी टर्शियरी को कर सकता. एंड यू कैन से एसिटलाइट्स, it is going to give, cyanides, it is going to give its corresponding cyanide. When alkyl halide treated with AgCN, isocyanide is formed. Alkyl halide react with KCN, alkyl cyanides are formed. Cyanides are called nitriles, isocyanides are all called isonitriles or carbylamines. And it can react with esters, carboxylate salts to form esters. It can react with water, solvolysis takes place, you are going to see the alcohols. So in one slide, the total alkyl halide reactions आपका दे सकता हूँ मैं. That is very good and it follows everybody. Take a screenshot. 3, 2, 1. Why is Br is a good leaving group in these reactions? So leaving ability. I minus is a good leaving group as compared to Br minus is a good leaving group as compared to Cl minus, and F minus is a poor leaving group. And this is going to be a good leaving group. Betu, you understand your doubt? Perfect now? Sobia, you are not asking doubts. Nitin, Subhashini, Sobia, come on. I want the flow of doubts should come. Okay, moving ahead. Here, nucleophilic aromatic substitution. You know, due to resonance, haloarenes do not undergo nucleophilic substitution reactions. If you want to take at room temperature, reaction आगे नहीं बढ़ेगा. If you use 300 atm pressure, 675 Kelvin temperature, extreme temperature के हिसाब से ये वाला एसिड हाइड्रोलाइसिस करने के बाद आपको मिलेगा OH. So this is what is called nucleophilic substitution reaction on the aromatic ring. You say it is SNAR2, but मैं क्या बोलना चाहता हूँ, अगर कुछ इलेक्ट्रॉन विड्रॉइंग ग्रुप कहीं भी लगा हो तो चाहे इसका नाइट्रो ग्रुप हो सकता, SO3H हो सकता, CN और डायज़ोनियम ग्रुप भी हो सकता, and it is going to give a nucleophile can easily attack to gives rise a nucleophilic aromatic substitution reaction. I wanted to say haloarenes do not undergo nucleophilic substitution reaction at room temperature due to stability and due to resonance. Carbon to halogen bond has partial double bond character. Assertion reasoning question भी ऐसे आ सकता है. Assertion nucleophilic substitution reaction is not possible for the haloarenes, and haloarenes do not participate in nucleophilic substitution reactions. The reason, due to resonance, the bond between the halogen and the benzene has partial double bond character. Why so? Already explained in the previous classes. In the general organic chemistry electronic effects, आपको पता चलेगा. You just want to watch the recordings, you can just see. Otherwise, if still have a doubt, please let me know in the chat box. I can schedule a special class for that and you can entertain that. So these NEET YouTube classes are absolutely free. We don't ask anything. You need not have to pay. To have this high level exactly NEET related questions and NEET related sessions, you need to join in a NEET coaching center. You have to pay a lot and you have to travel a lot, but simply sitting at home for free of cost, and you can enjoy and you can get NEET rank from this YouTube channel. So we agree with that. Now moving ahead, so this sigma complex is otherwise called a Meschen-Hammer complex, and you can get, as the number of electron withdrawing groups increases, reactivity also increases. It is given in the NCERT textbook like chlorine, NO2, 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 just simply add sodium hydroxide and acid hydrolysis later at room temperature. Okay, at room temperature, just warm it, no need to heat up to 675. You are going to get nucleophilic substitution reaction like this. So which of the following is going to be more reactive in the nucleophilic substitution reaction? If a strong electron withdrawing group exists on either ortho and para but not at meta positions, is going to increase the stability of this Meschen-Hammer complex. So you can get an assertion reasoning type questions, you can directly get these questions. So undoubtedly you are going to get a question from here because it is there in the NCERT. NCERT is everything. You agree with that? Everybody take a screenshot. Bacho. So, bacho, here electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reactions. So, the electrophile benzene actually, though it has 3 double bonds in it, it do not behave like alkene because the pi electron system on the benzene is completely delocalized above and below the plane of the hexagon of the benzene ring. Because of this pi electrons are delocalized, it is not allowing to come and interact with the electrophile. Alkenes undergo electrophilic addition reactions and benzene do not undergo electrophilic addition reactions. Hi Sonali, hi, how are you? Came late. So what happened? Rather, due to delocalization of the pi electron system, this benzene is going to participate in the substitution reaction rather addition reaction. It's an outstanding concept. सो नीट एग्जामिनेशन आजकल असर्शन रीजनिंग क्वेश्चंस में भी ज़्यादा फोकस दे रहा हूं. सो इसका हिसाब से मैं क्या करूं? Assertion, benzene do not undergo electrophilic addition reaction. Assertion, benzene, though it has 3 double bonds in it, do not behave like an alkene. Reason, due to delocalization of the pi electron system, the benzene do not behave like an electron. Okay, अभी तो मध्य प्रदेश में है आप. Okay, very good, let us see. So the electrophile, मान के चलो ये हाइड्रोजन जो है ना आपका कन्वीनियंट के हिसाब से, ये जो पाई इलेक्ट्रॉन्स इसका इलेक्ट्रॉन का क्रैप करके यू आर गोइंग टू गेट ये पाई कॉम्प्लेक्स and you are going to get a sigma complex first, and this is going to be a sigma complex is the intermediate. This is going to be resonance stabilized, and again this proton is lost to gives this electrophilic aromatic substitution reaction, and this sigma complex is very important. Now अगर ये बेंजीन इलेक्ट्रॉन रिलीजिंग ग्रुप होगा, शायद ये पॉजिटिव मेसोमेरिक होगा, तो the incoming electrophile should come at ortho position or para position. The product is going to be ring activation, and ortho and para products are going to be formed. If electron withdrawing group is there, so it is going to have maybe minus M effect. So the electrophile, you cannot attack at ortho and para positions because position of the ortho and para is with a positive charge. अगर electrophile आ सकते हैं तो electrophile क्या होगा? Positive charge species. It cannot come and attack here. ताकि सिर्फ मेटा पोजीशन में आने का संभावना है. So the product that you are going to get, thank you Sonali, the product you are going to get, if the benzene is having an electron releasing group, the product is going to be ortho and para products, and if the electron withdrawing group is there, the product is going to get only meta. And example दे सकता हूँ पॉजिटिव मेसोमेरिक इफेक्ट के लिए, हाँ मैं दे सकता हूँ, एंड चाहिए OH होगा, OCH3 होगा, एंड NH2 होगा, एंड नेगेटिव मेसोमेरिक इफेक्ट के लिए NO2 होगा, एंड COOH होगा, एंड CHO होगा, anything. So this simple thing can give you many reactions. What are some common electrophiles? 5 golden reactions of benzene are available. Betu, I will give you the 5 golden reactions of benzene in today's class itself. You just stay tuned. Within 10 minutes I am going to give that. Okay, moving ahead, here these are the 5 golden reactions of benzene. Benzene when react with chlorine, that reaction is called hallucination, and in that chlorine is going to be Cl plus is going to be the electrophile. Betu, got it? And the product is going to be chlorobenzene. This is going to be hallucination. Benzene when it is treated with HNO3 H2SO4, it will have nitration, nitrobenzene, so that nitration mein nitronium ion is going to be the electrophile. Which of the following Sandmeyer reaction already completed in the previous class beta, if you remember. Sonali, you can watch it. You want me to tell again, I will tell you. Which of the following is a electrophile in this reaction? You have to check what is the electrophile here. And also you can see benzene react with sulfur trioxide in the presence of H2SO4, you are going to get benzene sulfonic acid. उसमें sulfur trioxide खुद ही एक electrophile होगा. All reactions that are shown here are going to be irreversible reactions. And सिर्फ a reaction reversible होगा. And also you can see alkyl halide react in the presence of AlCl3 gives us alkyl benzene, and usme R plus is an electrophile. And this reaction is called as a Friedel-Crafts alkylation. And RCOCl gives rise RC double bond O plus, and this is resonance stabilized, and you are going to get acyl benzene. This reaction, what you can say, it is a Friedel-Crafts acylation. So you have 5 golden reactions of benzene, and these are the electrophiles, and this reaction is electrophilic aromatic substitution reaction. आज का हम सेशन में we are discussing about all major high yielding, mark yielding reactions. Take a screenshot everybody. 3, 2, 1 कर दिया. Can I have, okay, Sonali, can I leave electrophilic aromatic substitution? No. Electrophilic aromatic substitution is such an important reaction, so we can't leave it. And moving ahead, direct effects of electrophilic aromatic substitution reactions. This is a super amazing topic in the NEET examination. अगर नीट में क्वेश्चन आएंगे तो इसका हिसाब से आने का संभावना है. You just see here, this is OCH3. Okay, already a group is there. If chlorine AlCl3 होगा तो you are going to get a chloro, orthochloro, metachloro and parachloro. In that, it is going to be a major product is going to be para product. Why does Friedel-Crafts alkylation is not a rearrangement? The carbon of chain ion like alkylation. Alkyl carbocation can rearrange. Acyl carbocation do not rearrange because it is in the resonance. Carbonyl carbon do not rearrange. Fine. Now this is the way, because it is having a positive mesomeric effect. Because it is having a positive mesomeric effect. So positive mesomeric effect के हिसाब से ये ortho and para products होगा. Let us see the details about this. Exactly. So resonance in the anisole, you can see the lone pair of electron is coming ताकि negative charge is accumulated in ortho and para position. So that negative charges appear at ortho and para position. This is the resonance hybrid. Are you getting or not? Clear, my dear students? Here this resonance hybrid, अगर electrophile आने का, you are going to see if electrophile is attacked, it can attack here, it can attack here, it can attack here. When it is attacked, these are the sigma complexes. But if you take these sigma complexes, ortho and para are going to be the major contributors. Generally, ortho and para is going to be major as compared to the ortho, because ortho thoda sa steric hindrance milega. Hi, Ram, white signs. Now, as a result of this, it has a less activation energy for the ortho product. In general chemistry reaction, reactant is going to give rise a product in such a pathway that it has a less activation energy, is going to be the major product. High activation energy is going to be the less product. So you can say when anisole react with this, para product is the major product. Assertion, reason, activation energy का हिसाब से भी पूछ सकता. So the activation energy for the para product is going to be the less. Sigma complex formation for the para product is going to be less for the activation energy. So this is going to be the major product. So as a result of that, you can see this is a major product. So this is the proper explanation. Simply writing the reaction, you know it and you well know it. If the question is asking something else, we need to know it. बच्चों ये क्या करना, आगे कैसे जाना. Similarly, activating groups, I just want to give strongly activating groups are there: OH, OR, NH2, NR3. Moderately activating groups are there: SH, SR, OC double bond OR, and NHC double bond OR. Weakly activating groups are there, like alkyl groups or phenyl groups are there. So, by looking at this, you can say whether it is activating or not activating, or ortho and para directing, or something else. The reactivity increases because of the activity increases when the activation increases. Similarly, one more example I want to say: nitro group is electron withdrawing. When the electron withdrawing group is there, it deactivates it. Because of this electron withdrawing nature, the major contributors, it gives rise positive charge on the ring. So it is a resonance hybrid. As a result of this, what happened? Nitrobenzene, when it is chlorinated, the major product is going to get as a meta director. Similarly, the same logic I just want to use. Why so? When nitro group is attacked at ortho, meta, and its para, you are going to see various sigma complex structures. Electron meta directing को कर सकता हूँ, so भी and the meta is going to be the major contributors. So as a result of this, activation energy for this one meta is going to be the same is repeating, activating groups and all. Okay, this is going to be the unstable one at para and ortho. So this is not that great stable, but it is there. So I just want to say the activation energy for the meta product is going to be less, and as a result of this, it is going to give the beta chloro product, strongly deactivating CF3 and O2 NH3 plus, moderately deactivating groups, and of course here the chlorine is there. It is weakly deactivating, but exceptionally it is ortho and para directors. Of course, this is an exception. Whenever halogens comes, you consider the halogens as minus I effect is there and plus M effect is there. Plus M effect is not actually considerable, you consider minus I effect. Strong minus I effect का हिसाब से you have it is a strong deactivating, and because of the weak plus M effect, you are going to see it is going to be ortho and para director. Like that, so many questions are there, and we still have to discuss this, and time is limited. आज कल इतना है, and अगले और एक session आपको देना है, and in that we will be discussing about various aspects, connected mechanisms with Neymoud reactions. So as time is exhausted, and if you have any doubts, please let us know. If you have any doubts, Sobiam, White Science, Sonali, and Beto, fine. Now the time is being exhausted. Signing off, Suresh, Faculty of Chemistry from Infinity Land NEET YouTube channel. Thank you. Please like this session, share with your friends, and subscribe to Infinity Land NEET YouTube channel. फिर मिलेंगे for more such type of sessions. Thank you very much.